So I'm going to talk next about sharing plant data with phones, tablets, the cloud, and really just about anything else. Now there's two main reasons why you would share data. The first reason is that you may want to view that data. You may, and we talked about this, you heard this in the unidirectional session. You may want to be able to get that information on the corporate network. You may want to share it with a business partner. And I'm going to go over another example of that. But if it's done correctly, the only risk you have to sharing data is the confidentiality of that data. The other reason for allowing remote access to a control system would be for controlling the ICS. And that would be actually allowing someone to operate the ICS from the corporate network, from the internet, from a business partner network. Blinding to the speaker up here. So those are the two main reasons for allowing remote access to your ICS, and we're going to talk about both of those and the considerations for security for those two and also some protection options for those two. But I'd like to start with maybe my favorite data sharing ICS application that's been going on for a very long time. GE, large American company, sells turbines for power generation around the world. And they also sell a control system for monitoring and controlling these turbines. And they have a service that is based here out of Atlanta that can talk to 1,800 of their turbines in 60 countries around the world. So from Atlanta, you have at least the ability to monitor all those systems and usually the ability to control all those systems. And I would argue that this is probably the most high-value target for anyone to attack in the ICS world. Because if you can compromise this system in Atlanta, you can potentially shut down 1,800 power plants in 60 countries. Now, there's some good reasons why they're doing this, and there's really great benefits to GE as well as to their customers for this. They call this their OSM, their on-site monitoring. And in fact, all the communication coming out of Atlanta, they call their Atlanta Data Highway. So they have this service that they sell. So one of the benefits to GE is their customers pay them for monitoring these systems. So they make a little bit of money. But I don't think that's really the major benefit for GE. Because GE, as you can see in the numbers up there, is getting a tremendous amount of information about the turbine performance. So they, for example, can decide how they should improve their product in the future, or what other features or service offerings they should do in the future. And probably most importantly, whenever a GE turbine fails, they can look at the data for that turbine and they can compare it to all the other turbines that they're monitoring. And they've identified, as you can see up here, and this is a couple of years old, they've identified more than 60 failure modes that can tell them a turbine is about to fail. So they can then provide this very useful service to their customers. Now, from a customer standpoint, why would you want to do this? Well, let me give you a simple example and maybe a more complex example. There are parts in this turbine that need to be cleaned every 6 months on average. And so the maintenance schedule for a power plant is to clean these every 6 months. Well, if you're in an environment that is very dirty, or a dust storm has come through, or there's construction in the area, that part might get dirtier faster than expected. And GE can look at the performance of the turbine, and it can tell you, you need to clean this part after 3 months, not 6 months. And when you clean that part, your turbine runs more efficiently, and you generate power more cheaply. So that's a simple one. Probably a more important example would be in those failure modes that I was talking about. GE can actually tell you this part needs to be replaced. If you do not replace this part in the next 3 months or 9 months, it will fail. So if you have that information that this part is going to fail, you can schedule an outage. You can have the people there who know how to replace the part, and you can have the part there. So you can have a very short, planned, managed outage, as opposed to if you didn't get that information, you would then have to just wait till the thing breaks, have an unplanned outage, maybe cause a loss of power in the region for a prolonged period of time. It's a lot of bad things can happen. Unplanned outages are very bad. So from a customer standpoint, this is great. My system can run more efficiently. I'll reduce my unplanned outages. From a GE standpoint, this is great. I get paid by my customer for this valuable service. I get all this information on my product to know how to make it better, and maybe I can even sell them additional services or features in the future. So it's really a very useful service. But of course, there's a downside. Right now, companies or countries around the world, Russia, China, and quite frankly, the United States, have organizations in them that are being tasked with being able to shut down parts of the critical infrastructure in their enemy systems, or potentially enemy systems. So you can imagine a government might say, we need to be able to shut down the power grid in country A, country B, country C, country D. And then a team of offensive security experts figure out how to do that. Well, they could go to each individual country and try to figure out how to do that, or they could try to hack into Atlanta, because a lot of those countries are going to have power systems managed in Atlanta. So this Atlanta data highway and these systems in Atlanta are a big, fat, juicy target to many organizations that would do these bad things. Now, if you were to talk to GE, and I have, and they've given public presentations on this, they would say, we have very strong security. We have all these things that you see up here. We have two-factor authentication tokens and encryption and firewalls. And we do background checks on all our users. We have really strong security. And I believe GE is telling the truth in this. I believe that GE takes the security of this system very seriously. The problem is, if you've read the news over the last 5 years or even the last 1 or 2 years, you'll read about organizations that take security very seriously getting hacked all the time. Anytime the target is this valuable and a well-funded, motivated, and talented organization wants to get in, there's a good chance they're going to get in. I mean, for example, this background checks, it doesn't even have to be a technical attack. They could simply blackmail someone who's allowed to get into the plant, or do something nasty to their family. Again, we're talking about governments and organizations that might be willing to do some pretty serious things to have the capability to take down 1,800 power plants in 60 countries. And what these attackers are realizing is it's easier to take down one central site than 1,800 different sites. I'm sure some of you are familiar with this headline. This is an example showing you that they are understanding that this is an issue. So this is a company called Telvent that since this has been purchased by Schneider Electric, a very large ICS company. And an attack that was attributed to the Chinese went into Telvent, got onto their network, stole project files. So these are the things that explain exactly how the ICS works. It has all the points and displays and other information that is essentially a roadmap or a blueprint for the ICS. So they stole that information. And then they also, now this is unclear, this has never been publicly acknowledged, but they also may have been able to access customers via this because Telvent had connections to their customers. So again, this would be an example of rather than attacking Telvent's customers, you attack Telvent, and then from there you can get to their customers. This is also, sometimes you'll hear this called watering hole attacks and other types of attacks where you attack a central site rather than each individual company. The other thing to realize is that even though organizations take information seriously, information has a way of just getting out there. So these same GE turbine systems, turbine control systems, are installed by GE engineers around the world, and they have installation notes that tell them how to install these. So this is one that you can find just through a little searching on the internet, and it has, I've whited them out, but it tells you all the passwords for the switches and network infrastructure that GE puts in when they put in one of these turbine control systems. And this type of information is out there as well. So the real question is, how can we get the benefits of this great service from GE? Customers like it, GE likes it. How can we get that? We certainly don't want GE or someone from Atlanta having the ability to control our power plant or shut down our power plant whenever they want. But we'd like to get this service from them. And the simple answer, and you heard some of this this morning in the unidirectional presentation, is you push the ICS data out. Because for GE to provide all this service, and other vendors are providing similar service, and you're going to get more providing it in the future under this big data, cloud computing type of buzzwords that you're hearing. How do you get it? You push it out to them. They don't need the ability to get on a system that can get control. They just need access to the data. So this is very similar to the diagrams that you saw this morning. And there's the TX, RX, that's the Unidirectional Gateway. And so in the original installations, most of them to date, GE would actually get, or whatever big data company would get all the way from this server through the internet, through the firewalls, and all the way onto the ICS where they can control the power plant. With a solution that is much more secure, they push the data out this way to a server outside the security perimeter. Now that data is still at risk. Someone in Atlanta could do something to that data, but again, it's just data and they're supposed to have that data. It's a risk to the confidentiality. But they can't get in here because it's a unidirectional gateway. Now you could say, I don't want to deploy a unidirectional gateway, I want to deploy a firewall, and I'll show you some of those. It doesn't have to be this, but the big thing is, don't let anyone into your network. Give them the data where they need it. Push the data out to them. Okay, so that was a big data cloud example. And obviously a very serious example because It could have such ramifications to so many countries around the world. But let's look at the example of, let's say I want to see data from my SCADA or DCS on my iPhone or my Android phone, or a tablet, or a laptop computer when I'm in a hotel somewhere around the world. The answer is really the same. You push the data out. So in this case, we're looking at a firewall rather than a unidirectional gateway. So in this case, your historian down on your plant network would push the data to a historian on the DMZ. Now, some people would just stop there. Some people, oops, did it again. Some people would just let everyone get the data there. You probably would be better off if you would then push the data from the DMZ out to a historian on the corporate network. And then some people even take it the next step further. They'll actually have a DMZ off their internet firewall and push the data out there. But what we really care most about is we don't let them through here. We don't let them down to the plant network. That's the key point. Whether you want to do this with a unidirectional gateway or a firewall with a very tight rule set, don't let them in. Okay, so let's look at a couple of examples here. The Pi server is probably the most popular historian in the world. There is an OSIsoft Japan, there's an OSIsoft almost anywhere. That's the vendor that makes the Pi server. And it's very good at accepting data from any data source. So you pick your favorite vendor, you know, Toshiba, Hitachi, Schneider, GE, Alstom Grid. Any vendor will have a way of sending data to the Pi server. Now there's other solutions, so I don't want you to get hung up on Pi, but we're going to use it as the example because it's kind of the market leader. This could be a GE prophecy historian, or many vendors have their own historian. So it could be any type of historian. But what these historian vendors are doing now is they're actually developing products. So the Pi version is a product called Coresight that will actually make it easy to pull data out of that historian that is sitting on the office network or on the DMZ. And again, all you're able to do is view this data. You have no control capability. It's monitoring only. And the real trick in doing this sort of thing is creating these displays. So just like you had to create displays for your SCADA or DCS, you'll need to decide what kind of displays you want on your mobile devices. They probably will be a different format because they're going to be a smaller screen. You may not want to provide all the data because there is a cost to pushing the data out. You have to build the displays, and you probably have to buy what's called tags or points from the vendor. But there is a way of doing it. If you go to this link, and let me stop here and I'll go to it. This is actually an application that talks to the Pi server, and it's pulling historical data that's updated, I think, every minute down here, and you can put this on your iPad, or you can access this anywhere on the internet. So you can actually go here to, let's say we'll go to the Northeast region, and we'll pick the Exton power plant, and then we can decide which trend we want to look at. So these are KPIs, are key performance indicators. You know, so we can look at the fuel, we can look at the fuel cost over time. You could have any sort of display or dashboard that you want here. It's really just limited based on what data do you want to send out what data you want to send outside of the ICS, and then how you want to display it. And again, this example is based on Pi, but you're going to see this on just about any type of system you want. And I want to remind you one more time, all you're seeing here is data. You have no control capability. So you might, I'm not saying you don't have to worry about the confidentiality of the data. That's a business decision you have to make. You know, maybe you don't want to be passing certain information out to mobile devices, even if they are secured. But at least you don't have to worry about someone taking down your plant, your factory, your pipeline. Okay, so the key thing I want you to walk away here from on this monitoring part is if you're responsible for the control system, you're going to get an increasing number of requests from people in your organization saying, I need the ICS data. And a lot of times, security people are known as the people that always say no. You know, don't ask the security guy, he'll tell you why you cannot do it. But in this case, you can say yes. You can say, yes, I can provide you the data. What do you need? And you have a methodology. Before they even ask the question, you know how you're going to provide the data for them. And you can even tell them how much it'll cost. So if they say, we want to get 1,000 tags or 1,000 points, and we need these 10 displays, you can say, well, 1,000 tags will cost us this much money, and it will take us, 3 weeks to build those 10 displays. Here's your bill. Once you give them that price to do that data, then the business can say, is it worth the money to push that data out? Because one of the things that we've seen is people often ask for all the data. They say they want all the data. The same thing they could see in the control room, they want to be able to see on their phone. And they really don't need to. It's just curiosity more than anything else. So if there's a price attached to it, they can decide, and they have to make the business decision. Is access to these key performance indicators or these trends worth that money? So monitoring, viewing data, push it out, say yes. That one's easy to solve, even all the way down to the iPhone in someone's basement or out at a bar. You really don't care because they're not going to be able to affect your control system. Where it gets a lot more dangerous and a lot more interesting is when it comes to control. Now, I'm not saying that you should not have the capability of controlling your system, your control system, remotely. So your ICS from a remote location, you probably need some way for emergency remote access. And the reason I say that is there will come a time when your plant or your pipeline or your train system or whatever control system you have is in a very bad state. Either there's great danger to your equipment, possibility of a long-term outage, or something that is really a catastrophe that could happen, and the man or woman that could fix that might be a 1 or 2 day travel away from getting there to help out. And if you don't have an emergency remote access method for that person, you will find people connecting cables all sorts of ways to provide access. So what you'll have then is very insecure remote access. Because again, it's an emergency, they're going to do whatever they can to get the right person access to fix the problem. So what you really want to do is you want to have a secure emergency remote access capability in place before it's needed. So this is just a quick outline of what we typically recommend. We recommend you create a DMZ just for that purpose, just for emergency remote access, and deploy a jump server in that DMZ. So basically, when someone is trying to access the network, they will connect to this jump server, and from then, that jump server, they will be allowed into the control system. But once you have this set up, you then physically disconnect it. So it's not operational, it's down. And then when an emergency occurs, based on some sort of policy and procedure you have in place, then the operators in the control room push a button or flip a switch and the circuit closes. Okay, now remember, these are control system engineers, so they know how to do this sort of thing. They know how to create circuits that can be controlled from the control room. This is very basic stuff for them. And then the other key thing is that after a certain amount of time, you can decide if it's 2 hours or 4 hours or whatever you want, that circuit opens up again. So you don't worry about someone leaving this emergency remote access on all the time. And then also this emergency remote access should be logged, and you should have a process for reviewing that log. So if the operators are turning this emergency remote access on 3 times a week, you don't really have emergencies. You have a fragile system. You have a system problem that you need to diagnose and fix. If it's 3 times a year, those are truly emergencies. Okay, so you definitely want to have an emergency remote access capability. You just don't want to use it very often, and you want to make sure there's no way, a physical disconnection, there's no way that it can be used. Now I'm going to make an assertion next. I'm going to claim that on almost every ICS deployed today, a motivated and moderately skilled attacker can easily gain access to that ICS, regardless of what sector you're in, and with few exceptions based on what security you're using. And the way they're going to do that is they're going to compromise a computer or system that has remote access to the ICS. Now this is a pretty bold claim, because you're saying, well, wait a minute, we have talented engineers, we have talented technical people. There's not going to be a way that someone's going to be able to take control of their computer. They're not that gullible. They're not that easy to fool. At S4 2013, and you can watch this on the Vimeo channel, this whole presentation, we actually challenged someone to prove this. So the company Critical Intelligence partnered with a company called FishMe, and we set them up with 3 of our pipeline customers. So 3 people that actually run SCADA pipelines. And all we gave Critical Intelligence was the names of those 3 companies, no other information. And we said, we want you to try to do a spearfishing attack to compromise computers that are allowed to remotely access the control system. Because if they could compromise those computers that remotely access the control system, they could run a keystroke logger and grab credentials, they could hijack a connection, they could do a lot of things. So, Critical Intelligence spent about 1 day doing open source intelligence, and you see here they found a lot of employees looking at Facebook and LinkedIn, and I'm sure there's a number of other places you'd look to do Japanese open source intelligence. But it was very easy to find a large number of employees, but the key one was they were looking for employees with business titles that meant they would likely have remote access to the control system. So you see 23, 49, 45. They found a lot of good targets, people they wanted to try to compromise their computers. They then did an open source intelligence to say, which control systems are these companies running? And then created a message that looked like it came from that company. So this is actually one of, they didn't publish the more specific ones because they didn't want to give away who the companies were. But this company was using Rockwell Automation, Allen Bradley equipment, and they wrote them an email about a white paper or a maintenance bulletin that they might be interested in. So someone who is responsible for these systems gets an email saying, hey, here's an important bulletin, you should read this, from somebody that they get these bulletins from. And it says, please click on this link, or in some other examples, please open this attachment. And if they were to do that, and this link was to a compromised website with an attack, a zero-day attack, or more likely the attachment had malware that the antivirus engines wouldn't find, then they would be compromised. So here were the results. About 25% of the people they sent the email message to either clicked on the link or opened the attachment. And this guy, the third pipeline, when he saw the 45 names, he stopped the project. He was too scared, and he said, no, we can't do this. But the two that moved forward, they sent it out, and 25% of the people clicked the link or opened the message. So this means an attacker now has access to those machines that took that action. And I think this was the best slide in their whole deck. These were some of the titles of the people that clicked on that link or opened that attachment. Some of these people probably have remote access to the SCADA system. So now you're in. And this is why remote access is so dangerous. In fact, there was kind of a funny story that the control room supervisor actually clicked on the link 3 times. They clicked on the link the first time and it said, this was a security test, please contact so-and-so. He went back to the email, clicked on the link again, got the same thing, and did it a 3rd time. And that's very typical for a user. They just can't understand why they're not getting what they're supposed to get. Now, I want to make sure you don't take the wrong message from this exercise, this spearfishing exercise. Some people see this and they say, the number one thing I have to do is stop spearfishing, stop my employees from clicking on spearfishing emails. This will fail. You cannot do this. Even the company FishMe that does spearfishing awareness training, that's the product they sell, they said they can only get a good company. The best they see is a company gets down to 10% of the people click on it. So you are not going to stop spearfishing. Now what you can do is the 90% that report it to security, you can have a process to deal with it quickly and track down what happened. But the real thing you have to learn is that you cannot allow computers, whether they be on your corporate network or your phone or your tablet, to remotely connect up to your control system. It's just too dangerous if that computer is doing email and accessing the internet and doing other things. There's just no safe way of doing that. And if you think ICS spearfishing is just a myth, there's been very active campaigns in the United States against the oil and gas industry and against the water industry. ICS-specific spearfishing. Unfortunately, nobody publishes those messages, but this was one we got back in June of 2012. We actually got an ICS spearfishing message sent to us, and I guess I didn't realize how rare it was. We thought it was kind of interesting, so we put it out on the internet, and it ended up getting picked up by the Washington Post and New York Times and all these people. I guess no one publishes these. But this was a really good example, because that paragraph right there is a paragraph I wrote on our blog. So that is my writing. This PDF name is the name of a PDF of a research paper that we did, I think it was for S4 2009. So this is very realistic. The only mistake they made was I never signed my name Peterson, and the email addresses look a little wonky. The other thing that happened, and I'd like to say that all the Digital Bond employees are so brilliant that no one fell for this, but we really didn't have a good test because it got sent to the employees and one of the employees was no longer with the company and his email forwarded to me. So I saw this and I said, whoa, this is interesting, and I sent out a message to everyone, hey, watch out for this. And of course, what happened was, and you'll hear about this tomorrow, everyone created these environments and started running the malware to see what it did because it was interesting. And this shows you the danger of antivirus, because this malware that was attached was only detected by 7 of the 42 antivirus vendors. And it's very easy to change malware, to recompile it or adjust it so that antivirus will never catch it. And the only reason the 7 caught it was because I don't think the attacker cared. None of the big guys caught it. Symantec, McAfee, Kaspersky, Trend, none of them caught it. It was just these ones that I had never heard of that caught it. So what happens is the attacker will actually attach malware that he's already tested and verified you will not find. So this is really happening. So why, with all these dangers, let's look at why people allow remote access to the ICS. And I like to break it down into 2 reasons: convenience and cost. Convenience is the one that we should really be able to deal with. All too often, we will see someone sit on their corporate computer and access displays on the ICS, so they'll have like a remote HMI, remote operator station, on their corporate network computer when they could just walk down the hall and go into the control room and see the data. But it's just easier to do it from their desk so they don't walk down there. You know, or they might, you know, they might have 2 computers and they just don't want to switch the A-B button back and forth. Okay. Convenience is a very weak argument. We need to get around that one. That one seems pretty easy. The tougher one is cost, because the whole reason that we do automation projects is that we can run very complex processes with fewer people, right? We do automation, one of the main reasons is to save money. And we've reduced the staff to such a level that the people that we need to maintain this aren't always there. So we can, let's say, maybe have fewer people on our 24/7 shift if we allow them to remote access in 5 times a week when we need their help. And this is a tougher argument. I'd like to say I have the perfect solution to this, but I really don't. One partial solution is to go back to our monitoring example and push the data out to them, the data that they need. And then they can look at it, and then they oftentimes can call someone in the control room and tell them what to do, and then watch the change. And we've actually found for most organizations, this will address a large percentage of the remote access. But you may actually, if you're requiring people to do activities on a daily basis or a frequent basis on your network, that person probably needs to be on a control system network somewhere, or at least not on a machine that is used to access the internet, access email, do that sort of thing. I guess I would like to maybe end, although I have a couple of pictures for you after this, by encouraging you not to give up on this, because a lot of people have said, this is a done deal. It's over. In fact, one of the major industry advisors in the United States, and they actually have a global presence, the ARC Advisory Group. I actually think there's an ARC Advisory Group Japan. They have said that not only is this going to happen, but you should make sure that the application on your iPhone or your tablet or your Android phone has a control capability. And someone from this group, when we were giving a presentation at DHS, stood up and said, well, you know, that what you're saying about remote access sounds good, but we have to accept that 20-year-olds are going to be controlling plants from their basement or from their small mansion or apartment on their iPhone. And I guess I would just encourage you to fight against that, because once you allow someone to do this from an untrusted device, you've lost your integrity and availability of your control system. But there is a big push to do this, and I just had a couple of pictures here. So this is, I believe, is the Iconics app on the left. You know, and they make a major push, and ARC Advisory Group says you can use this for control, you should use this for control. You have similar things on the right, you have tablet displays and all sorts of things. So this is actually happening, and there is going to be pressure on you to do this. Now the funny thing is, if you look back at these, don't these look a lot like the monitoring apps that I showed you at that demo at Transpera? So it's not so bad that you have this information. It's just when you get to that control capability that we need to be really careful.